Welcome back everyone to another math video. What are matrices? Part 2, operations on matrices. Today, we talk about an unexpected topic you probably would not have been able to guess from the title because it is deceptive. But we are going to actually talk about different operations you can do on matrices. Well, on that note, I'll see ya. Matrices Part 2, operations on matrices. There are four main operations you can do on matrices: addition, subtraction, multiplication, and can you guess the fourth one? I bet you can't. Scalar multiplication. Haha, bet I tricked you. You were expecting division, eh? Not anymore. Okay, but enough of teasing you for not knowing what you are not expected to know. Time to talk math. There are four main operations on matrices, but today I'm only going to talk about three: addition, subtraction, and scalar multiplication. So far I'm saving matrix multiplication for another day, and maybe explaining why there is no such thing as matrix division for another day too. I guess if you want either video sooner, make sure to let me know down in the comments section. Who knows, maybe you will be the one person who comments on this video. You never know. Well, anyway, all you really need to know is that there is no such thing as matrix division, and there are two ways of multiplying when it comes to matrices, the normal and the scalar multiplication, but you will learn more about multiplying later. So now we start with matrix addition. I'll be honest, matrix addition, along with subtraction and scalar multiplication, all work pretty intuitively. By intuitively, I mean you can probably figure out how to do this by yourself. By figuring this out by yourself, I mean matrix addition works just like normal addition. What do I mean by this? Let us have two matrices that we are adding. Boom. Just like magic. How do you think we could add them? You probably have a guess already, but here is the answer. Just like magic. You probably know the pattern by now, but if not, then here it is. Basically, when you are adding matrices, you add the corresponding elements. If you don't know what an element is, you can watch my previous video, appearing right now at the top right of the screen. But basically it refers to the numbers. So we could add the numbers in the corresponding locations, and that is how we would get our answer also in the corresponding location. This also works for all of the other elements. However, warning, big warning, there is one catch. All of the matrices having the operation done on them, whether they be addition or subtraction, must have the same order. I mentioned order in my previous video, but an order is basically the dimension of the matrix. Maybe you will understand me more on the next slide. I have a 3x3 matrix and I am trying to add it to a 2x2 matrix. How would I do this? Well, the simple answer is you can't. Each element does not have a specific, unique, corresponding element in the next matrix. What if we add the top left element to another top left element? What about the top middle element? Also, what would the order of the solution matrix be? Overall, to add matrices, along with subtracting them, all matrices must be the same order. Moving on to subtracting matrices. To start, I will say that matrix subtraction works a lot like normal subtraction. Seeing a pattern? If you know how matrix addition works, chances are you also know how matrix subtraction works, but I'll explain it anyways. So if you have two matrices and are trying to subtract them like so, exactly like matrix addition, except with subtraction, you would subtract the corresponding elements to get your solution matrix. Remember, your matrices, all of them, even the solution matrices, must have the same order. So all this talk about scalars and scalar multiplication with matrices, but what is a scalar? A scalar is a real number. That's it, nothing too big. So if a scalar is a real number, numbers like 1, 0.8, the square root of 2, even negative 2/3 would all be scalars. So what would not be a scalar? The square root of negative 5, for example, would not be a scalar. Remember, a scalar, or a real number, is a number that can be graphed on a number line. So now we know what a scalar is. What is scalar multiplication? To start, matrix scalar multiplication involves multiplying a matrix by a scalar. pretty self-explanatory. For example, if we were given the scalar 3, for example, and we're multiplying it by this arbitrary matrix, what would we do? Well, if matrix addition and matrix subtraction weren't any hint to you, we would just multiply the scalar by every element inside the matrix to get a solution that looks like so. If you still didn't catch on, we would multiply the scalar with each element of the matrix, and the product would be where the corresponding element would go. Hello everyone, this is me during editing, and I just wanted to say that the reason I didn't go over matrix multiplication today is because, unlike scalar multiplication, matrix multiplication involves multiplying a matrix by another matrix. And it's not as simple as you may think. It's not just like multiplying the top left number by another top left number and that's what you get. It actually utilizes rows and columns, and it's actually quite complicated to explain, so that's why I saved it for a complete other video. So this is just me explaining why I didn't do matrix multiplication in this video. Well, back to the video. So now we learned about 3 operations on matrices. Time to apply them. Did you know we can mix and match operations? How cool. Let us have matrix A and matrix B. Now to mix and match operations. Let us find 3a plus 2b. Here we have both scalar multiplication and matrix addition. Now how would we find the answer? First, we must remember that if we are given a, 3a would mean we should multiply matrix A by scalar 3, so 3a is equivalent to this. Of course, the same would apply to matrix B. We would multiply matrix B by a scalar of 2. Now we have converted 3a plus 2b into actual numbers of 3 times matrix A plus 2 times matrix B. But before adding, I must first caution you. We have to remember that 6th grade still exists, and that order of operations is a thing. While not in this problem, first comes parentheses, then exponents, then multiplication, then adding and subtracting. So we would multiply the matrices before adding the matrices. Applying order of operations, however, you should have gotten the answer to be this matrix. Well, that wraps up today's lesson, and it's time to move on to the Cliff Note slide. Time to take out your cameras, everyone. Well, anyway, we learned that there are 4 main operations you can do on matrices: addition, subtraction, multiplication, and scalar multiplication. I only went over addition, subtraction, and scalar multiplication today, not multiplication. But what is a scalar? A scalar is a real number. Also, there is no such thing as matrix division. Also, matrix addition, subtraction, and scalar multiplication all work as you would expect them to. I mean, it's pretty intuitive, I guess. Haha. Well, anyway, thank you everyone for watching. If you have an idea for a future math video, make sure to comment down below. Be the one person who comments on this video. Well, anyway, if you like this video, make sure to smash that like button and hit the subscribe. Well, anyway, thanks for watching and have a good day. Bye.